Lesson 7-8, Graphing Inequalities in Two Variables. And in this lesson, you learn to graph inequalities in the coordinate plane. Why is it important? Because you can graph inequalities to solve problems involving manufacturing and health. And let's take a look at a real-world application in manufacturing. Rapid Cycle Incorporated is a manufacturer and distributor of racing bicycles. It takes 3 hours to assemble a bicycle and 1 hour to road test a bicycle. Each technician in the company works no more than 45 hours a week. How many racing bicycles can one technician assemble, and how many can he or she road test in 1 week? Okay, so this is again a word problem, and in any word problem we need a let statement. So let X represent the number of bikes that are assembled in a week, and let Y represent the number of bikes that are road tested. So if you notice, we have two variables in this word problem. Okay, so then the following inequality can be used to represent the situation. Okay, so if your total time to assemble the number of X bikes will be 3X. Okay, we add that to the total time to road test Y bikes. Okay, so it's no more than is an inequality of less than or equal to 45 hours, because that's the maximum that they can work for each week. Okay, so there are an infinite number of ordered pairs that are solutions to this inequality. The easiest way to show all of these solutions is to draw a graph of the inequality. But before doing this, let's consider some simpler inequalities. We will solve this in example 3. Okay, so let's take a look at example number 1 from the set of 3, 4, 0, 1, 1, 4, 1, 1, which ordered pairs are part of the solution set for 4x plus 2y less than 8. First, let's use a table to substitute x and y values for each ordered pair into the inequality. If you use the point ordered pair 3, 4, we end up with 20 less than 8, which is false. Okay, and if you use the ordered pair 0, 1 and substitute that to our inequality, we end up with 2 less than 8, which is true. We use inequality 1, 4. We end up with 12 less than 8. Again, that is false. And finally, if we use the ordered pair 1, 1, 6 less than 8 is true. Okay. So if you notice, okay, the ordered pairs 0, 1, 1, 1 are part of the solution. 4x plus 2y is less than 8. Okay, so the graph above shows the four ordered pairs of the replacement set, and the equation 4x plus 2y equals 8. So this is our graph. Okay, and these are your four replacement sets, the four dots that are there, 3, 4, 0, 1, 1, 4, and 1, 1. Okay, and this is the equation of the line 4x plus 2y equals 8. Okay, so you have 4x plus 2y equals 8. Notice the location of the two ordered pairs that are solutions of 4x plus 2y less than 8. These are 1, 1 right here and 1, 4. Sorry. The ones that are true are 0, 1 right here. Okay. Point that. This is 0, 1 right there. Okay. And we have 1, 1 right here. These are the two that are true. These are the 2 points that are true. The other 2 points are false. Okay. So notice where they are located in on the side of our line. Okay, they're on the left side. Okay. Now let's move on before we. Okay. So to be able to do that, let's take a look at this one. After we've seen that, the solution set for an inequality contains many ordered pairs when the domain and range are the set of all real numbers. The graph of all these ordered pairs fill an area on the coordinate plane called a half plane. An equation defines the boundary or edge of the half of each half plane. For example, if you wanted to graph the inequality y is greater than 5 in the coordinate plane. Okay, before we do that, let's go back to our example. So we have a half plane. A half plane is called, okay, the graphs of all the ordered pairs fill an area of the coordinate. That means these are all the ordered pairs that will make the inequality true. it's located in that half plane. And the equation of the inequality is called the boundary. Okay, so going back, okay, going back to our original problem right here. Let me do that again. Okay, and this becomes our inequality right here. So it says here that you have 2 points that make the inequality true, 0, 1, and 1, 1. Okay, and the line, okay, is the equation of our inequality. So 4x plus 2y equals 8 will be the line, and this is called the boundary. Okay, and if you notice, everything, okay, any point that you try to the left of your boundary right here will make this inequality true. Okay, and this is the half plane which makes it true. Okay, so if you try, for example, the ordered pair is 0, 0. Okay, if you do 0, 0 here, so 0 plus 0 less than 8, that would be true, because now everything to the left of that boundary will make it true. On the other hand, everything to the right of that boundary will make the inequality false. Okay, let's go back here. So we have an inequality y is equal to 5. First thing we need to do is we need to draw the boundary, okay, of y equals 5. Okay, so first we need to determine the boundary by graphing y equals 5. So when we graph y equals 5, okay, let's do that. Dotted line and then 2 arrowheads. Okay, and we make it red. Okay, so y equals 5 is right here. Remember, y equals 5 is, that doesn't work. Change that one. Make it thin. There, 2 arrowheads. Now it works. So y equals 5 would be that. Okay, that is the boundary, y equals 5. Now why is it dotted? Why is it not solid? Because, okay, everything on that boundary is not included in the solution. Remember when we talked about solid dots and open dots? Okay, it is an open dot, okay, when it's greater than or less than. Okay, it is a closed dot when it's greater than or equal to or less than or equal to. In the same manner, if it's less than or greater than, it's a dashed line. And if it's greater than or equal to or less than or equal to, it is a solid line. Okay, going back here. So we graph y equals 5, and that's what we got. Okay, so since the inequality involves greater than, the line should be dashed. The boundary divides the coordinate plane into half planes, and we just discussed why it's a dashed line. Okay, so it divides it into 2 half planes, the one on top and the one at the bottom. Okay, so to determine which half plane contains the solution, choose a point from each half plane and test in the inequality. Okay, so let's try 7 and 10. 7 and 10, oh, it won't work. Let's just try 3 and 6. So instead of 7 and 10, we'll try 3 and 6 because our graph is not big enough to handle 7 and 10. So if you try 3 and 6, okay, and we have the inequality y is greater than 5, and we let y be equal to 6 instead of 10, okay, and now we have, okay, 6 is greater than 5, which is true. Okay, so this point right here, 3 and 6, right there, will make our inequality true. Okay, now let's try the point 4, 0, which is going to be on the other side of the half plane, and we'll see if this makes our inequality true or not. So we get our inequality y greater than 5 when we equate y to 0, because 0 is our y coordinate. And if we replace y with 0, we find out that this will make our inequality false. This simply means that all the points to the on the bottom part of our half plane will make inequality false, and everything on the top part of our half plane will make our inequality true. And that means we simply have to shade the top part of our half plane, and that's how you graph the inequality y is greater than 5. Okay? Now let's take a look at this example, and uh, let's graph y plus 2x is less than or equal to 3. First things first, we need to solve for y in terms of x. That means we need to isolate y on the left side of the equation. That means we need to subtract 2x to both sides, so isolate y. So end up with inequality y is less than or equal to 3 minus 2x. So with that said, first, when we want to graph this inequality, we need to find the boundary, the equation of our boundary, which is y equals 3 minus 2x. That means we need to graph this first, graph y equals 3 minus 2x. And since we're using the inequality less than or equal to, we need to have a line that is a solid line. Okay, so it's less than or equal to, we're going to have our boundary will have a solid line. So let's recall how to graph this particular equation. Y equals 3x, and then y equals 3 minus 2x. Okay, we can rewrite this as y 3 equals negative 2x plus 3. Now if you notice this is in slope-intercept form. Your slope would be negative 2 over 1, and your y-intercept would be 3. Okay, so first we plot our y-intercept, which is 3 right there, and we use our slope to be able to find our other point, which is negative 2 over 1. We go down 2 times. Oopsie, let me undo that thing. We go down 2 times. 1, 2, and we go to the right 1 time, and that is our other point. So we connect those 2 points. Okay, we end up with that line. Remember, it's a solid line because it's less than or equal to. So to be able to find out which side to shade, okay, along our boundary, the left side or the right side of our boundary, we test a point. Okay, so in this case, a good point to test would always be 0, 0, or the origin, because it will make it solving or computing a lot easier. So if we use 0, 0 as our test point, which is right here on the left side of our boundary, okay, we use our point right here. The half plane that contains the origin should be shaded. Okay, why is that? Because if we substitute the value 0, 0 to our inequality, so y plus 2x less than or equal to 3, okay, 3, and we substitute the point 0, 0, that means it's 0 plus 2 times 0 is less than or equal to 3. If you notice, 0 is less than or equal to 3, which will make the equation true. If that makes our equation true, that point right here, so that means we need to shade that part of our half plane. Okay, so this simply means that everything, okay, on the left side of the boundary, all the points on the left side of the boundary will make our inequality true. Okay, so if you want to check this, let's find the point on the other half of our half plane, and let's use the point 3, 3, which is right here. So if we use the value 3, 3 and substitute it back to our inequality, it will make a false statement, because if you have y plus 2x, that's right, less than or equal to 3, and substitute the point 3, 3, if you notice, you have 3 plus 2 times 3 less than or equal to 3. It will make the inequality false, because this now becomes 9 is less than or equal to 3, which is absolutely a false statement. Okay, so 9 is less than or equal to 3. Less than or equal to 3 is a false statement, and that's the reason why we don't shade the right part of our boundary, okay, or our half plane. Okay, so let's take a look at the last example. When solving real-life inequalities, the domain and range of the inequality are often restricted to non-negative numbers of whole numbers. Okay, let's refer back to the application at the beginning of the lesson. How many racing bikes will the technician be able to assemble and road test? Again, we need to solve for y in terms of x. Again, that means isolating y on one side of the equation. So we copy the inequality, solve for y by subtracting 3x to both sides. And then you have y is less than or equal to 45 minus 3x. Okay, so if we to be able to graph y is less than or equal to 45 minus 3x, we need to graph the boundary y equals 45 y equals 45 minus 3x, which becomes a solid line. Again, why is it a solid line? Because the inequality is less than or equal to. So test a point in one line of the half plane, for example, 0, 0. So the half plane containing 0, 0 represents the solution since 3 times 0 plus 0 is less than or equal to 45 is true. So what it's saying is this. First, we need to graph y equals negative 45 minus 3x. And we graph this using the slope-intercept form where your slope is negative 3 over 1 and your y-intercept is 45, just like this one. Okay, so your y-intercept is 45 and you have a slope of negative 3 over 1, and that's the graph that you come up with. Again, why did we shade the left side of our boundary? Because we tested the point, the origin, okay, and the origin is on the left side, and which made our inequality true. So that means we shade that part of the inequality. Okay, so again, let's examine what the solution means. The technician, okay, cannot complete negative numbers of racing bikes. That means we only have to deal with, okay, one quadrant in our coordinate plane, and that would be the quadrant number 1. So any point on the half plane whose x and y coordinates are whole numbers is a possible solution in this case. That is only the portion of the shading in the first quadrant is the solution for this problem. So one solution would be 5 and 30. So instead of shading the entire thing, we only shade the first quadrant because you cannot have a negative value in this type of a problem. Okay, so this represents 5 bicycles assembled and 30 road tested by the technician in a 45-hour week. Okay, and the secret word for this particular lesson would be trek. Again, the secret word is trek, T-R-E-K. And that's our lesson. Thank you for watching.